Welcome to the comprehensive guide for the Aster Stream AIoT Energy Management System. In this video, we will walk you through the entire process of deploying our intelligent energy solution, from on-site hardware installation to cloud platform operations. Aster Stream Tech Pte Limited, based in Singapore, provides a robust, three-tiered architecture designed to monitor, analyze, and optimize your energy consumption. Our system consists of the field device layer, which includes meters, sensors, and HVAC equipment, the edge computing layer, powered by industrial IoT gateways, and the cloud platform layer, hosted at AsterStreamBuild.com, which delivers AI analytics, ESG reporting, and real-time dashboards. Whether you are managing a commercial office building, a factory production line, or a large hospital, this guide will equip you with the knowledge needed to successfully implement and operate the Aster Stream system. Let us begin with the hardware installation process. The foundation of the Aster Stream system relies on accurate data collection through carefully selected hardware. Our system is compatible with market-leading equipment from Advantech, Siemens, Schneider Electric, Honeywell, and Moxa. The first step in any deployment is conducting a thorough site survey. This involves confirming the specifications of your electrical system, including main incomer and branch breaker capacities. You must also identify mechanical equipment such as chillers and air handling units. Crucially, assess the network environment to ensure availability of Ethernet, Wi-Fi, or 4G LTE signals. The outcome of this survey is a detailed point list that maps each monitoring point to its corresponding device and address. Once the site is surveyed, we proceed to hardware wiring. For modbus RTU devices, which use RS-485 communication, devices are connected in a daisy chain topology. It is essential to install a 120 ohm termination resistor at the farthest end of the chain to ensure signal integrity. The maximum transmission distance is 1,200 meters at a 9600 baud rate. For BACnet over IP devices such as modern chillers, connections are made via industrial switches on the same subnet as the IoT gateway. With the physical connections established, the next phase is configuring the IoT gateway. Log into the gateway's web user interface and set up the modbus polling parameters, typically polling every 30 to 60 seconds. You will need to configure the upload target to the AsterStreamBuild.com using your unique API key for authentication. To optimize data transmission, set the batch size to 50 writings per call and the upload interval to every 5 minutes. The gateway also features a local SD card cache capable of buffering up to 72 hours of data during network outages, ensuring no data is ever lost. Finally, ensure your network firewall allows outbound TCP traffic on port 443 to AsterStreamBuild.com. The Aster Stream architecture is highly secure. It requires no inbound ports as the gateway operates on a one-way outbound upload mechanism. If using a cellular connection, we recommend a 4G SIM plan with at least 2 GB of monthly data. With the hardware installed and transmitting data, we now move to the cloud platform setup. Customers must operate the main website to unlock the system's full potential. To begin, you need to register an account on the Aster Stream AIoT Management System at AsterStreamBuild.com. After your enterprise account is approved, log in and select your preferred subscription plan, either Standard or Enterprise, and complete the payment process. A 14-day free trial is also available. If you require API access for your gateways or third-party integrations, visit the Aster Stream API portal at AsterStreamTech.com to register an account. Once registered, navigate to portal.AsterStreamBuild.com to generate a new API key. Select the appropriate permission scopes, such as Energy Right for Gateway Uploads. This API key is permanently bound to your company's tenant ID and must be entered into all on-site gateways to authenticate data transmission. Inside the main platform, navigate to the Sites menu to add your facility. You will enter details such as the site name, address, floor area, electricity tariff, and the local grid emission factor. This information is vital for accurate cost calculations and ESG reporting. Next, register your IoT gateways under the IoT Gateways menu. Input the gateway name, model, and connectivity type. The system will generate a gateway token, which must be copied into the on-site gateway's heartbeat setting to confirm its online status every 60 seconds. The final setup step is registering individual monitoring devices. Under the Devices menu, add each piece of equipment, specifying its type, brand, communication protocol, and rated power. The system will assign a unique device ID, which must be provided to the site engineer for input into the gateway configuration. This ensures that the incoming data is correctly mapped to the virtual representation of your equipment in the cloud. The AsterStream platform offers a suite of powerful features for daily energy management. Let us explore each feature in detail. The energy monitoring dashboard provides a real-time view of your plant's power consumption. It displays today's cumulative usage, monthly totals, and dynamic comparison charts against previous years. You can easily filter the data by specific sites or individual devices, allowing for granular analysis and hotspot identification. Additional tools include electricity bill calculation, demand management, and billing history records. Our platform leverages advanced artificial intelligence models, including XGBoost and Profit, to analyze equipment data every 15 minutes. The system generates actionable optimization recommendations, complete with confidence levels and estimated savings. For example, it might suggest raising a chiller set point from 6 degrees to 7 degrees Celsius during peak hours to save 8% in energy, with a confidence level of 91%. You can choose to accept these recommendations for automatic execution via the gateway or perform them manually. The system will track the savings over a 7-day verification period. Predictive maintenance is a key benefit of the AsterStream system. By continuously analyzing current, temperature, and vibration data using an isolation forest model, the platform can predict equipment failures before they occur. It provides a failure probability percentage, estimates the remaining useful life in days, identifies the root cause, and recommends specific maintenance actions. For instance, if a compressor shows a 72% failure probability with an estimated 18 days of remaining life, the system will immediately alert you to schedule a maintenance inspection, helping you avoid costly unplanned downtime. The platform also supports ISO 50001 compliant operational control schedules. You can set time-based or demand threshold schedules to automatically issue control commands to your equipment. For example, you can schedule a chiller to operate from 7:30 in the morning to 7 in the evening on weekdays, with automatic shutdown on weekends. For sustainability requirements, the ESG carbon reporting module calculates Scope 1 and Scope 2 emissions using local grid emission factors. It supports international standards such as ISO 14064, GRI, and TCFD, allowing you to easily export PDF reports for regulatory submissions and supply chain disclosures. The alert management system monitors critical thresholds and notifies you via email or SMS. Alerts are triggered when demand exceeds 450 kilowatts for more than 15 minutes, when a device goes offline for more than 5 minutes, or when the power factor drops below 0.85. The system can also automatically activate energy-saving mode in response to these alerts. Security is paramount at AsterStream. All API communications utilize HTTPS with TLS 1.3 encryption. Our multi-tenant architecture ensures strict data isolation. All server-side queries enforce tenant ID checks, making cross-tenant access architecturally impossible. Your data is completely segregated from other companies on the platform. In terms of resilience, gateways buffer up to 72 hours of ratings on the local SD card and automatically retransmit all data with full timestamp integrity upon network reconnection. Our enterprise plan guarantees a 99.9% uptime service level agreement backed by daily PostgreSQL database backups. To illustrate the real-world impact of the AsterStream system, consider this case study from Singapore. A 10-story commercial office building with 15,000 square meters of floor space and approximately 180,000 kilowatt-hours of monthly consumption deployed. 3 Advantech WISE-66, 10 gateways, 12 Siemens PAC 3220 meters, 25 temperature and humidity sensors, and 6 wireless vibration sensors on pumps. The result was an average energy savings of 8 to 12%, with predictive maintenance alerts arriving 2 to 4 weeks in advance. The payback period for the hardware and annual subscription was approximately 18 to 24 months. In summary, the AsterStream AIoT energy management system provides an end-to-end solution for intelligent energy monitoring and optimization. From selecting the right IoT gateway and wiring your field devices, to configuring the cloud platform and leveraging AI-driven insights, every step is designed for reliability, security, and measurable results. Thank you for watching this complete deployment and operations guide. For further assistance, please visit our platform at asterstreambuild.com or contact our support team at aster.stream.tech@gmail.com. We look forward to helping you achieve your energy efficiency goals.